Alrighty, round two. Welcome back. Cheers. Little apple juice. All right, so today, actually, I'll reintroduce the whole thing and myself. If you're new here, which you probably aren't, but if you're coming back to check this out, my name is Marcel. I am starting a business called All City Services, and on the side while I work for someone. And I'm documenting the business process and also doing a lot of content to build the business and see where that takes me. I've done hot water since 2013, so like 12 years, coming into my 13th. I've been plumbing for close to 20. Just started my 20th year, so my apprenticeship started in 2006. And I've installed and worked with a lot of domestic hot water. And today is going to be learn how to diagnose an element or a thermostat fault on an electric water heater. So let's get right into it, eh? Overhead camera shot. I'm going to get our OJ as well. Sorry, apple juice. Now, this is a thermostat. You may recognize it, you may not. Doesn't matter. That's like a switch. Basically acts as a switch to let power to the element or stop the power going to the element when it gets to the right temperature. This is the element that goes into your water heater. This goes on a flange. This part is inside the water heater doing the heating. That's what gets hot. And if you pay attention to it, you can see it's actually just a loop pretty much. So power, it kind of works like an old light bulb with a filament. Power goes through here and out, in and out these these cables rather. So this all works together. Oh my lord! Up here, camera. It's like this auto zoom. Now, so power comes into the thermostat in here. It goes down to the element in the thermostat here. And then that's where the first element cable connects onto. So one of these connect to there. And the other one connects to there. So this goes to the element. Does the heating. Then it goes up to this guy here. And then to this fella. And then to the neutral, back to the board. Neutral, which is usually black. This is the active, usually red. So that's basically the circuit. And on the back of this are two discs. So this top disc, you can actually, I don't know if you can sort of see here on the thermostat, it says ECO 84. Diff 88, a diff 8 I think is like a tolerance, 8 degree tolerance, but that ECO stands for emergency cutout. and it cuts out if the water gets to 84 degrees. So these discs are like a bimetal disc, so two metals there that expand at different rates, and as they get hot, they'll pop. So one metal will expand faster than the other, and sort of there's like a bit of a concave in the disc, and if it expands enough, it sort of clicks. And that click is actually a cutout, so they'll cut the circuit like a switch. You can't really see, but the reset button pops. That's if it gets too hot. The bottom disc is basically the exact same thing, but does it at different temperatures. So it'll pop at, depending on how much you turn this dial, which you can't actually see, but it ranges from 60 to 70. So this will pop at 60 or 70 degrees when it gets to a certain temperature, stopping the flow of electricity as it pops. So it pops, lifts the tab off the contact, and stops electricity passing through it. So metal disc pops up, lifting a switch. Let's say this is the power. So power's trying to get through here. It pops and it lifts that off there. If it was closed, it would be popped down. We'd have this going across. They'd be touching. So power can't get through here now, but when this is functioning, the power goes through and sends it to the element. That way. So what you get between this point, that point, that point, and that point is one whole circuit when you have an element connected to it that functions. So now that we know how all that works, we can get our Klein Tools multimeter. Wowee. Hit me with a sponsor, Klein. And we set it to the Wi-Fi setting. So it looks like a Wi-Fi symbol. It actually is symbolizing a beeping noise, which can test continuity. And continuity is like basically that a circuit is complete. So there's a whole circuit, not unbroken circuit. It continues, testing the continuity. Now let's get a light on that, just so you can see. So we get our active and neutral. Well, we get our Watts-image jiggies here. If we touch these together, it'll beep. So if this whole circuit is complete, we're going to get a beep across these two. So in and out through the element. So that's beeping. So if I'm going to actually remove the element and sort of do a little bit of a pretend element. Pretend that this is the element. Chuck that in here. Oh my gosh. Get in there. Bear with me, folks. Bear with me. Pop that there. Pop that there. All right, let's pretend that's our element and that's working. We'll get a beep. So if we have a break in the thermostat, if there's a fault in the thermostat in this little switch mechanism here, let's say that's popped down and the power wants to get through, but these contactors here, let's say they're burnt out, which is what normally happens. let's say that fizzles, blare, that's gone burnt, and the power can't get through anymore. What you'll be able to, the way you'll be able to test that is with the continuity test. So testing that it can actually get power flowing through it. So I'm just going to simulate a burnt out thermostat. Oh, come on. I just popped the ECO on the thermostat. Get up here. Come on. Come on, camera. All right, so if we put our what's these here, oh, it's the camera's automatically going to there. Now, let's start again. If we put our multimeter on those 2 points here, we should get a beep if it's not broken. So right now, the circuit's open and it's not beeping. So there's a problem. When you're diagnosing it in real life, you can go start with these two and go, okay, there's no continuity here. Obviously turn the power off, don't be a waffle. No continuity here. What's going on? I want to check. Next, you can check the element. If we get a beep there, what we're testing is the loop of the element only between here and here. So what that tells us is the element's good, but the thermostat's not. So we go from here to here, no circuit. From here to here, no circuit. So that tells us the thermostat's had it. Now, if thermostat's good, let's reset it, and we have a break in the element. Let's say boom, the element has blown inside the tank and we don't know. They've got no hot water. They got power here. We're going to test this, bro. Up here, cuz. So we're going to test this. We get no beep. Now we can see if it's the element. Well, I guess you could just go straight to the element and you'd know straight away. Okay, no beep. There's no connection between here because the element's blown. But we can check the thermostat if it's good by putting it between these two and these two. So there's obviously continuity here, like these are connected between here and here. And that's letting us get a beep. And between here and here is good, but what's stopping it from here is the gap between these two. So remembering that the flow of electricity comes in here, goes down through the element and back up and out. So this is the element at fault there. All right, that is how you would diagnose an issue with an electric tank. Very simple stuff. Now there's a few like little, I don't know, not tricks, but just things you got to be aware of, I guess. Obviously, definitely turn the power off. You have to have a disconnect and reconnect license, which I've got, which is a pretty straightforward course. I'm obviously no Sparky. I don't understand how it comes in active and goes out neutral. Maybe someone can tell me about that. That does magic inside the element. Because when you actually measure the voltage on the active, it's 240, but then from the neutral it's not. But maybe a Sparky can enlighten me on that. But yeah, basically got to have the electrical disconnect license, have the power off when you're testing. But any multimeter should have that continuity testing option, the BP thing. I think that's the technical term. But this multimeter is pretty good. It's got a clamp meter on it, and it was like $50, something like that, from Bunnings. So you can test that a heater's drawing power with that guy. But yeah, don't be silly with electricity. That's the lesson for today. Let's get on to content thoughts, shall we? Today, what did we do content-wise? There was actually not a lot of work. I used some old content today, and I'm not really sure how it's gone, but let's get my... If you have a look up here, there's the phone cam, overhead phone camera. It's pretty fun. Yeah, I used some old stuff because there was not much work on today. Like literally none. I delivered a water heater. That was it. But an old time lapse that I used, I just did a voiceover on, but there was plenty of stories, and a bit of like reflective stuff, I guess, today. And I don't know if people have started realizing that I'm doing the same morning routine. So story when I wake up, or story when I head to the gym, story when the gym's finished, and then story when I dip. And that's basically my morning weekday routine. But I think what you post, if you basically you're going to attract an audience similar to your lifestyle, I guess, and that would be, I already said this, I think yesterday. The what you're putting out there is what you'll attract, I guess. And that's the sort of vibe I want to attract. And quality plumbing as well. Business thoughts. I don't have any business thoughts off the top of my head. I feel like there was something, but I can't remember. I'll come back to that though. But I'm pretty excited for what's to come. I was musing earlier today in the stories. This is actually more of a content thought. Let's go back to that screen. That the attention grabber is the social media stuff. So stories and posts that gets people's attention and then directs people. The idea is that it would funnel people to here on YouTube, and then YouTube would kind of if the business side of things becomes successful, then that will be shown here because I'm like documenting the actual business, and that'll be like really good social proof for leads. Ideally, also, if it ever gets to the point, employers, future employees rather. I'd like to like attract kind of people that are really interested in the trade and like learning about business and all that sort of stuff. And if I pull it off, then it'll open up doors to that, to like good employees, I guess. That's the thought process for me. And like as we go through it, I'll sort of be not pitching, but showing what kind of company I want to set up, and the sort of spirit of the company, and then that'll attract a particular avatar, they call it, I guess, for a customer, a particular customer. So who you're really trying to target. And the idea for me is like premium service at a premium price. That's really the simple way of putting it. But obviously, I don't have the the social proof yet to pull that off. But as things progress, you'll see where it goes. Now, we're on here. Oh, stats. I got me some more subscribers. 2 more. 30 subscribers. And the calculating the running costs. Oh yeah, actually got to do some housekeeping on that. I got a DM from Kev at I think it's Australian Hot Water. He's down at MacArthur. I'll just double check that because I don't want to get it wrong. But he put me onto a very simple solution to calculating running costs. Yeah, Australian Hot Water. So Kev's got a Australian Hot Water franchise down in MacArthur, and he showed me this ream cost estimator. Basically, let's see, what's my screen up to? Yes, everyone can see this. New South Wales. You can choose any of these water heaters and find out exactly how much it costs. Controlled rate. They don't really give you too much info here. Well, they give you enough info. But so this is sort of similar to what I was saying. I think I was at 20 cents per kilowatt hour. There we've got 19 here. I underestimated the energy use per year. So it seems like a lot still. That's like 12 kilowatts. I calculated it before. It's about 12 kilowatts per day, which is 12. Let's do 12 divided by 3.6. 3 hours of heating. Is that right? 12 kilowatts, 3.8, 3.6 kilowatts. Yeah, 3 hours of heating a day, which is, I'll just times that by 60. $60 liters an hour, 200 liters. Yeah, I guess that makes sense. So that seems pretty accurate. I probably underestimated that. But yeah, if you're interested, you can go through and kind of put in the details that you want to put in and get an estimate. But it looks to me, I've already said this before, that I can't see the maths in paying for a heat pump, and I can't understand the maths in paying so much extra for a heat pump and waiting so long to make your money back. But as someone said to me, if the customer wants it and they're happy to pay for it, sure, why not? It's easier on the environment. Plenty of benefits there, especially for the bottom line for plumbers. So that was a little update on yesterday's live stream. Now, stat mode. Did 0 today. We did 1 delivery. Pretty quiet day. Plenty of yard work at the boss's place. So we got our job numbers are all the same. YouTube subscribers has gone up by 2, which is nice. That was organic, actually. I didn't send any messages out. So good to see a little bit of growth there. And my the calculating the running costs. My last video got 2 likes. Woo! First likes on YouTube. Thanks to whoever that was. So I'm curious to check in like a year's time and see what the numbers compare like. All right, I'm going to call it a night. Let me know what you thought of this one, if you learnt anything with the diagnosing. Reach out, get in contact, message. Always happy to chat to anyone. Love making connections, especially in hot water land. So get in touch. And Patrick, Johns, your stickers are coming. They're all wrapped up in an envelope. They'll be out in the mail tomorrow.